We'll now look at section 2.2, where we will discuss linear equations in two variables. We will begin with a definition. A linear equation in two variables, say the variables x and y, is an equation that can be written in the form ax plus by is equal to c, where a, b, and c are constants, and a and b are not both 0. This form of such an equation is called the standard form. An example of a linear equation in two variables would be an equation where the a value is 5 and the b value is 3 and the c value is 2. That is an equation in two variables that is linear and in standard form. Specifically, what you want to watch for to know that you have a linear equation is that you do not have any visible exponents. While it's true that we do have powers of 1 on both the x and the y, we do not see those. If we had had a problem where we had an x squared or an x cubed, so forth, those are definitely not linear equations. Linear equations will typically have an x and a y raised to the first power only. Let's look at some examples. Determine if the following equations are linear equations. So we're going to take each of these equations, do some simplification, and try to determine if they meet the criteria for a linear equation. So let's begin with part A. 3x minus the quantity 2 minus 4y is equal to x minus y plus 1. In order to simplify, we're first going to take the subtraction and we're going to distribute it through the parentheses. So 3x minus 2, here we have a subtraction and a negative, which would make a positive. So positive 4y is equal to x minus y plus 1. We're now going to get all of the x's on one side. So we'll do that by subtracting an x from both sides. So that's going to give me 2x minus 2 plus 4y is equal to negative y plus 1. We'll now get the y's on the left side as well. We'll do that by adding a y to both sides, which is going to give me 2x minus 2 plus 5y is equal to 1. And now we'll get our number on the right-hand side. So we'll do that by adding 2. So we have 2x plus 5y is equal to 3. And we can see that this is a linear equation in two variables in standard form. So we'll answer yes to this one. All right, moving on to part B. We have 3x plus 2 times the quantity x plus 7 minus 2y equals 5x. We'll begin by distributing the 2. So 3x plus 2x plus 14 minus 2y equals 5x. Then our goal is to get it into standard form. And so we will move the x's to the left. So we'll subtract 5x. This is going to give me negative 2x plus positive 2x plus 14 minus 2y is equal to 0. Note your 2x and your negative 2x cancel out. And so you're left with 14 minus 2y is equal to 0. Remember, we're aiming for standard form, so we'll move the 14 to the right-hand side by subtracting it off. So we have negative 2y is equal to negative 14. And we can divide both sides by negative 2 in an effort to simplify, and we end up with y is equal to 7. Now, this is a linear equation in standard form. Let's go back and look at our definition for just a second. Our example is y is equal to 7. And so does this fit the standard form? In this case, the a value, the number in front of the x, is a 0. The b value, the number in front of the y, is a 1. And the c value is 7. And we're told that a, b, and c are constants, and a and b are not both 0. So the a value can be 0 as long as the b value is not. So yes, this is a linear equation in two variables written in standard form. Let's look at part C. We have x plus 2 over 3 minus y is equal to y over 5. This equation might be easier to work with if we will go through and multiply by something to cause the fractions to disappear. So since we have a denominator of 3 and also a denominator of 5, multiplying by the product of those two numbers, which would be 15, would cause both fractions to simplify out. So let's do that. 15 times x plus 2 over 3. 3 goes into 3 once. 3 goes into 15 5 times. So we're left with 5 times x plus 2. We also need to multiply this 15 times the y. So we have 15y. Over here, 5 goes into 5 once. 5 goes into 15 3 times. And we're left with 3y. We'll now distribute the 5x plus 10 minus 15y is equal to 3y. We will combine the two y's, and we'll do that by subtracting the 3y off from both sides. So we have 5x plus 10 minus 18y equals 0. And then we'll move our 10 to the other side. And so we have 5x minus 18y is equal to negative 10. And we can see now that that is a linear equation in standard form with two variables. So again, we're going to answer yes to this one. Okay, let's look at part D. Part D has 7x minus, and the quantity in parentheses 4x minus 2 plus y is equal to y plus 3 times the quantity x minus 1. So again, let's distribute first so that we deal with the parentheses. We're going to distribute this negative, so 7x minus 4x plus 2 plus y. On the other side, y plus, and we're going to distribute the 3. 3x minus 3. I'm going to go ahead and combine the 7x and the negative 4x, making 3x, and rewrite the rest of the expression. We'll now move our x's to the left, so we're going to subtract the 3x. So it cancels on both sides, leaving me 2 plus y is equal to y minus 3. We'll now attempt to move our y's to the left-hand side by subtracting a y. It cancels again on both sides, leaving me 2 is equal to negative 3. So this is not a linear equation. It's actually a false statement, which means that it has no solutions, but it's not linear because we don't have any variables left. And so we're going to answer no to this one. For part E, if you look at part E, you see that it has a power of 3. So if it has a power of 3, we know immediately that it is not linear, because we know that in simplified form we can only have powers of 1 on our x and our y. So I can go ahead and say no to number 3 without working it any further to part E. All right, let's look at part F. Now part F is a little bit deceiving because we do have some squared powers, but what we want to do is make sure that they do not simplify themselves out before we say that it is not linear. So let's very quickly simplify this one. X minus 3 squared means it's x minus 3 times x minus 3. So our problem now looks like x squared minus the quantity x minus 3 times the quantity x minus 3 is equal to 3y. I'm going to use my FOIL method to multiply the x minus 3 times itself. So first times first is going to give me x squared. The outside terms will give me negative 3x. The inside terms give me negative 3x. And the last terms give me positive 9. Now, note that I put that in a set of brackets because we have a subtraction out in the front that is going to need to be distributed. So distributing the subtraction, we're going to have x squared minus x squared plus 3x plus 3x minus 9 is equal to 3y. As you note what happens, the x squareds will cancel out, which tells me now that I am more than likely going to be dealing with a linear equation. Let's finish it up to be sure. 3x plus 3x gives me 6x minus 9 is equal to 3y. We can move the 3y to the left in an effort to get it in standard form. 6x minus 3y minus 9 equals 0. And finally, we'll move the 9 over to the right, ending up with 6x minus 3y is equal to 9. So again, a linear expression with two variables in standard form.